Now, example number 1, you'll be told the diameter of a bolt is a continuous random variable x with a probability density function f of x is kx into 4 minus x, and x is between the interval 0 to 2 or 0 elsewhere. Then you've been told to determine the value of k, to determine the mean, to determine the mode, and to determine the probability of x between the range 1 to 2. So from probability 1, we found out that the range of a probability measure is 1, isn't it? We said that the probability of an event impossible to occur is 0. Maybe if you toss a coin 10 times, if you get 0 heads, then the probability of getting a head is 0 out of 10, which is 0 over 10, giving you 0, meaning it is impossible to get a head from that experiment, isn't it? Then if you get 10 tails out of 10 trials, then it means the probability of getting a tail is 10 out of 10, meaning it is certain to occur is 1, isn't it? So the probability of an event impossible to occur is 0, and the probability of an event certain to occur is 1. So you see the whole of that interval is 1 with minus 0, you get the whole range of a probability measure to be 1, isn't it? So in a continuous random variable, in case of a probability density function, it means if you want the probability of a random variable x between the range a to b, if you integrate the probability density function over the whole of that range, you are supposed to get the whole range of a probability measure. Are you seeing that? If you integrate a probability density function over the whole range you've been given, you get the whole range of a probability measure. And the whole range of a probability measure is what? 1. Is 1. So what does it imply? In this question, you've been told to determine the value of k. So for you to determine the value of k, you simply need to integrate the f of x over the whole range, isn't it? So from here, what is f of x? So you can see there, f of x is kx times 4 is 4kx, isn't it? Then kx times negative x minus kx squared. Or maybe you can leave k outside and you take only x inside. That's another option, isn't it? You can leave k outside, so you end up with k into 4x minus. Are we together? Because k is a constant. There's no need of taking a constant inside. Okay? Now, what do you know? The whole range of a probability measure is 1. This probability is equal to 1. But how do we get it? You integrate the whole PDF over the whole of that range, isn't it? So our probability density function f of x is having from a range 0 to 2 is this, meaning 0 elsewhere means this. 0 elsewhere means the probability if the whole range is from negative infinity. If x is between negative infinity to infinity, then you are supposed to integrate from negative infinity to infinity of f of x dx. So if you start dividing, this one is from 0 to 2, meaning the lower part here, you are going to integrate from negative infinity to 0 of f of x dx plus, then the next part is from 0 to 2, which is given. Are you seeing that? The next part you integrate from 0 to 2 of f of x dx, then plus the last part is now from 2 up to infinity of f of x dx. And the whole of that range of probability measure is what? Is 1. So you can see this range from 0 to 2 is what we have 0 elsewhere means. If you work out this and the definition of this, you get 0. So it means only this range is equals to 1. Are you seeing what that means? Are we together? So that is why I'm saying the probability of x between the interval range, you integrate the whole range of f of x gets to be 1. So it means 0 elsewhere has taken care of the range of negative infinity to 0 and that with the given definition of the PDF. Are you seeing that? Are we together? That's why I'm not dealing with negative infinity to infinity. I'm just dealing with the range A to B because these other ones are 0 elsewhere. Are we together? So what do we have here? What do we have? Start with Roman number 1. Roman number 1, you'll be told to find the value of k, isn't it? To find the value of? So the value of k is going to be what? We are integrating from A to B of f of x dx. If we integrate that, we get the whole range of a probability measure, which is 1, what we've defined there, isn't it? Are we together? So what is A? A you've been given is 0, and B you've been given is 2. So it means we are integrating from 0 to 2, f of x. What is f of x in that range? In this range, f of x is defined by, so you can see k is a constant you can factorize outside, isn't it? Are you seeing that? Then inside here we have 4x minus x squared dx. Then after evaluating that integral, you are supposed to get what? 1. Are we together? So f of x is k 4x minus x squared over this range. And your k is a constant and factorize outside the integral, okay? So you start, so we have k into, if we integrate 4x, what do you get? See this? 4, you add 2, then you divide by 2, isn't it? Then it is minus, if you integrate x squared, so you add 1 to the power, and you divide by the certain power, isn't it? Are we together? Then after integrating that, you put the ranges from 0 to 2. And that one is equals to what? Is equals to 1. So from there, what do you have? We have k inside the bracket is upper limit minus lower limit. Then it is equals to 1. So upper limit you substitute 2 where x is. Are we together? So where x is, when you put 2, what do you get? So 4 over 2 in bracket 2 squared minus 2 cubed divided by 3. What do you get? Substitute 2 where x is. This one is 8. 8 minus 8 over 3. 16 over 3, isn't it? Are we together? When you put 2 where x is, you will get 16 over, because this is 8 minus 8 over 3. 8 is 24 over 3. 24 over 3 minus 8 over 3 is 16 over 3. Use a calculator. When you put 0 where x is, see this will be 0, 0. So you get the lower limit to be 0. Are we together?
Yes.
So from here, what do we have? 16 over 3 minus 0 is just 16 over 3, isn't it? Times k. You get 16 over 3k is equals to 1. So what is the value of k? You multiply both sides by 3 over 16, isn't it? Multiply both sides by 3 over 16. So you get k is 3 over 16. Is that okay? So the value of k is 3 over 16. So after getting the value of k, you go back to your probability density function, and where there is k, you will now be using the value of k to calculate anything that follows. Are we together?
Yes.
We've now found the value of k. After that, what else have we been told to determine? We've been told to determine the mean. So the mean, from the theory of expectation, the mean is given as the expected value of x. That is the mean. The mean is the expected value of x. So you simply multiply the PDF with x. Are we together there?
Yes.
You multiply PDF with x, meaning we are going to integrate from a to b, x times the PDF dx. That is the way to get the mean. It is x times the PDF. Are we together?
Yes.
So what do we get there? Give me the range from a to b. It's 0 to 2. So we have from 0 to 2, then x, then f of x is what? 3 over 16? 3 over 16 x times 4. So you get 3 over 4x. So this 3 over 16x multiplies everything inside. So 3 over 16x times 4, you get 3 over 4. See, 4 cancels with 4 in the numerator. So you remain with 3 over 4x. Then 3 over 16x times negative x, you have minus 3 over 16x. Here, from here, where there is k, you put the value of k, which was 3 over 16. So 3 over 16 times 4x, you get 3 over 4x. 3 over 16 times negative x squared, you get that. So the whole of this is f of x, isn't it? Then dx. So we have x times f of x. Are we together? The expected value of x is that x times x of f of x. Meaning if you have one, the expected value of x squared, it is x squared times f of x. Are we together? So what do we have here? Take x inside the bracket. We are integrating from 0 to 2. Take x inside. X times 3 over 4x. 3 over 4x squared. X times negative 3 over 16x squared. Negative 3 over 16x cubed dx. So it means we've now written this one in a form which we can now integrate, isn't it? And now, after we've integrated in that range, it means we found the expected value of x, which is the mean. So what do you get here? 3 over 4. If you integrate x squared, you get x cubed over 3, isn't it? Yeah. Are we together? Then it is minus 3 over 16. If you integrate x raised to power 3, you get x raised to power 4 over 4, isn't it? So after integrating that, you put the range. You are integrating from 0 to 2. Are we together? Is that okay? So what do we get here? It is going to be upper limit minus lower limit. So where there is x, you put 2. When you put 2, you are going to have 3 over 4 times 2 cubed over 3, isn't it? Are we together? Go to the calculator, 3 over 4 times 2 cubed over 3, then minus 3 over 16 times 2 raised to power 4 over 4. What do you get? What do you get? You can even as well simplify. 3 goes with 3 here. You remain with x cubed over 4 minus 3x raised to power 4 over 16 times 4 is 16. So you can simplify it like that. Then the range from 0 to 2, isn't it? So what do you get? When x is 2, where there is x, if you put 2, so you get 2 cubed over 4. Are we together? Minus 3 times 2 raised to power 4 over 64. What do you get with the upper limit? Calculator, please. 5 over 4. So the upper limit is 5 over 4. Then it is minus the lower limit. The lower limit you put 0. When you put 0 here, you get 0, you get 0. So 0 minus 0 is? So upper limit minus lower limit, you have 5 over. So it means the mean is 5 over, which is what in decimal? So the mean is 1.225. So you can see the values of x is ranging from 0 to 2, meaning the mean must be between 0 and 2, which you've seen here is 1.2. Are you seeing that? Because the values of x are ranging from 0 to 2. So for you to get the means of all those values of x, it must be a value between 0 and 2. Are we together? Good. So that is how to determine the mean. So having seen how to determine the mean, 1.25, so we found the mean is 1.25. The next thing we want is the mode. How do we determine that? The mode. How do we determine the mode of a probability density function? So the mode of a probability density function is the highest value. Are you seeing that? The mode is the highest value. How do you get the highest value? It is the maximum value where there are more data in that given probability density function, isn't it? So how do you get a maximum value? If you go back to calculus, when you were dealing with the case of a stationary point, how are you getting a maximum point? See, a maximum point is a turning point. Are you remembering? So if this probability density function, sometimes it is moving like this, meaning the maximum value will be at that point, isn't it? At the turning point, isn't it? And remember, the maximum value is where the data is considered. That is giving you the mode, the most frequent, isn't it? The maximum value in case of a continuous random variable. Are you seeing that? So how are you getting a maximum value? The maximum value you were saying, the derivative of the function at the turning point is 0, isn't it? Are you seeing that? Meaning for you to determine the mode, of a probability density function at the turning point, the derivative of the function is 0. Meaning the values at that point gives you the mode, the highest value, the maximum value. You see that? Yes. Are we together? Then you can use the second derivative to actually prove that is actually the maximum point. Are you seeing that? So the derivative of the function at the turning point is 0. So what is your function f of x? Your function f of x you found 3x times 4 you found is 3 over 16x times 4 was 3 over 4. X minus 3x over 16x times x. 3 over minus 3 over 16x minus 3 over 16 x squared, isn't it? See, this is the probability density function. Defining. This is the f of x defining that PDF, isn't it? Yeah. So if we differentiate it, what do we get? The derivative. If you differentiate 3 over 4x, you remain with 3 over 4, isn't it? Then if you differentiate this, you get 2 times negative 3 over 16. You get 2 times negative 3 over 16, so you get negative 3 over 8. Then you remain with x raised to power 1, which is just x, isn't it? See, that is differentiation. Are we together? Okay? So at the turning point, the derivative of the curve is equal to 0, meaning that turning point is the maximum value, isn't it? So at the maximum value, 3 over 4 minus 3 over 8x is equal to 0. So 3 over 8x going on the other side of the equation, you get 3 over 4 is equal to 3 over 8x. Are we together? So can you solve this? What is x? See, for you to get x, you multiply both sides by the reciprocal. 8 over 3. So 8 over 3 cancels to 8 over 3, you remain with x to be 3 goes with 3, meaning the maximum value is the point where x is equal to. Are we together? So you see that upper limit too is actually the maximum value for this probability density function. It is the mode. Are we together? It is the mode, and you can confirm that it is the maximum value by using the second derivative. If you differentiate this for the second time, what do you get? If you differentiate this, you get 0. If you differentiate this for the second time, you get negative. See, negative 2, 3 over 2 is less than 0. If the second derivative is less than 0, see, that is a maximum point. See, that is a maximum point in turning point, isn't it? The second derivative, because this is univariate, not two variables, 1, isn't it? So the maximum value x is equal to 2 gives you the mode. Okay? So it means the mode sometimes will not be the highest limit. Like in the previous cases, we were saying the mode, you just key in the lowest limit and you check, and the highest limit and you check which one gives you the highest value, isn't it? And that becomes the mode. But now we are now testing it with the derivative, isn't it? Are we together? So that is how to determine the mode. So we found the mode is 2. So the last thing they want, the probability that x is between 1 and 2. Can we get that? Can we get that? The probability that x is between the range 1 to 2, isn't it? Are we together? So remember, when you are looking for the probability that x is between A to B, you are simply integrating f of x between that interval, isn't it? So we are simply integrating the function between the interval from 1 to 2, and you can see from 1 to 2 is defined under this first part. Because you know here is from 0 to 2, meaning from 1 to 2 is still part of this interval. Are you seeing that? Because there is a situation whereby f of x will be defined with more than 1. Are you seeing? Are you seeing such cases? Yeah. So we are now 1 to 2 is between 0 to 2, meaning it is over that range, and that is defined by what? It is defined by that, isn't it? Are we together? Which is, what is f of x? So it is 1 from 1 to 2, f of x dx. Substitute f of x. What is your f of x? 3 over 16x times 4? 3 over 4x minus 3 over 16x times x? X squared. So we are integrating the PDF from the interval 1 to 2. Are we together? So what do you get? Start integrating. 3 over 4 if you integrate x, so you get x squared over 2. Are we together? Then it is minus 3 over 16 if you integrate x squared, so you get x cubed over 3. Then you put your intervals is from 1 to 2, isn't it? So can you simplify this before you start substituting? See, this is 3. In the numerator, 3 times x squared, you get 3x squared. In the numerator, 4 times 2, you get 8. Are we together? Then minus 3 cancels with 3, isn't it? You remain with x cubed over 16. Then the limits 1 to 2, isn't it? Are we together? So move there. Upper limit minus lower limit. So upper limit when x is 2. Where there is x, you put 2. What do you get? Where there is x, if you put 2, what do you get? It is 3 times 2 squared divided by 8 minus 2 cubed over 16. What do you have? Where there is x, put 2. You have 1. You have 1. Then when x is 1, where there is x, you put 1. What do you have? 5 over
16.
16. So what is the probability? 1 minus 5 over 16, which is 11 over 16. Are you seeing? The probability, the range of a probability measure is between 0 to 1. Any probability must be between 0 to 1. Any probability. This is probability, isn't it? Are we together? Good. So that is how to handle a probability density function. Example number 2.